So a little bit about ScyllaDB, the company behind the Scylla, the NoSQL database. Scylla is a NoSQL database, which is a drop-in replacement for Apache Cassandra and also for Amazon DynamoDB. I will talk a little bit about that later. With improved performance, in some cases 10x over Apache Cassandra and lower tail latency. Scylla comes in 3 variants. One is open source. You can go to GitHub, look at the code, download it, compile it if you like this kind of things, or use Docker, AMI, etc., RPM. There is also Scylla Enterprise, a closed source version of the database with some extra features, mostly about management and security. And last but not least, Scylla Cloud, a managed Scylla Enterprise version on the cloud that we manage for you, including monitoring and such, and available right now only on AWS, but we are planning to move to more clouds, and this webinar actually relates to that. Scylla right now is about 100 people, and we do hire. So especially if you're a developer, Go developer, C++ developer, we might have something for you. So a little bit about myself, and I will let Henrik present himself later in his section. I'm VP of Product at Scylla, working in the tech industry for something like 120 years, last time I counted. And mostly, or big part of my career was in telecom. I've been in Oracle and other places in the last 7 years or so in ScyllaDB. And with all of my experience, I have hard time switching between slides and Zoom. So what we're going to cover today, I talked a little bit about Scylla. We'll talk about Kubernetes and how Scylla and Kubernetes match. And the large chunk of today's presentation going to be from Henrik, actually demoing Scylla Operator and Kubernetes and explain a little bit about the architecture of Scylla Operator and why it's good. Later, I will discuss a little bit about the status of the project and what we plan for the project. And last, we'll have a Q&A session. So what is Kubernetes and what is Scylla? Scylla, so I'm sure most of the people on this session are aware of Scylla. It's a NoSQL database. It's a distributed database. So usually you have more than 3 nodes, can be hundreds of nodes in some cases, which can be hard to manage in some cases. It's how to outscale, how to downscale. You need to run operation like backup or repair. You need to do an upgrade, even a simple upgrade across 10 or 20 or 100 nodes can become a hard task. And this is where Kubernetes come in. It helps you manage all of this operation in an easier way. And the operator is basically trying to capture what a DBA would do and automate the processes. So if, for example, a DBA, either in his scripts, in Ansible or what's not, or in his brain, have the logic when and how to outscale Scylla, the operator can automate this function for you. And I just noticed that both Scylla and Kubernetes are actually words from Greek. So might be some metaphysical connection here that I just noticed. For those of you familiar with Scylla as a drop-in replacement for Apache Cassandra, there is another variant of Scylla, which actually is the same software, just a different API. Scylla recently implemented AWS DynamoDB API, which is unlike CQA, it's based on HTTP and REST and available in Scylla open source starting from 4.0. Everything that Henrik presents here today also apply for the Dynamo API, or as we call it, the alternator project. So you can run and deploy Scylla and Kubernetes and use the Dynamo API. And let me launch a quick poll here, trying to understand how many of you guys are using Kubernetes and are using Scylla. I will give you a few seconds to answer. And I won't tell the result in the end. Okay, I do see a lot of people voting, so I'll give you like 10 more seconds. I I don't want to stop anyone from his democratic right to vote in this poll. Okay, it looks like the number is stabilizing, so I guess most people voted already. Okay, and with that, I'm going to switch to Henrik. What Henrik will demonstrate is a typical deployment scenario with the Scylla Operator running on Kubernetes. So Henrik.
Thank you, Zach. And as you noticed maybe from the slide, I've been at this way too long. And for the past couple of years, I've been working as a Go developer here on Scylla, primarily on the driver and the manager and Kubernetes. So what do we need? We need a running Kubernetes cluster, of course. I will be running today on GKE in Google. It's simple, it's quick to get started, it's resilient, it doesn't crash too often, or ever actually. But nevertheless, you need a working Kubernetes cluster for it to try this out yourselves, which you will be able to do. Maybe Zach can send the link later. So here we go. First, what if someone can't see my text, please ping us, and I will try to increase it. Maybe I'll do that immediately. Here we go.
I think it's good, Henrik, at least from my side, I think it's good.
Great. So everybody needs monitoring. Without monitoring, we have it's very hard for us to look into the state of our Scylla world, right? And in the Scylla world, monitoring usually means Scylla monitoring, which is a project that we have derived from Grafana and Prometheus. In the Kubernetes case, these are deployed as regular Helm charts that exists for these projects outside of the Scylla world. They are just regular charts, and we simply configure them in a few ways to make it work for us. But it's all standard. There's nothing weird going on, particularly weird, depending on who you ask, of course. And as you can see, we have a few pods running. We have the server, of course, the Prometheus server. We have the Grafana instance in itself. Server I showed you. We have the alert manager, can be convenient. Next is to deploy the operator itself, right? Monitoring in itself is not very useful, but it together with actual apps that use the monitoring, it becomes pretty neat. And the operator is currently yes, it's a Kubernetes operator. It follows all the life cycles that the operator SDK mandates, and the hooks into Kubernetes, all of that. Nothing weird. But what's that without a cluster? Let's deploy it immediately and see what happens. There is nothing strange going on here. This line here looks horrible, and it is a little bit horrible, but we simply replace stuff like the GCP region, the zone, things that we want in our cluster YAML, and feed it to kubectl. Standard operating procedure, I would say, for Kubernetes. So what happened in the operator logs? Is there anything? Oh, yeah, there is a lot. Let's see if we can ever find some beginning here. We can. There are some interesting things to note here. Let me see if I can reduce the size a little bit. Great. Okay, here, this thing, take note. This is something we will see a lot, or I will explain later, but you will see it a lot in your logs. And things like this, it's a very good sign, right? It means that the operator thinks that its next action is to create a rack. And for all of you who are familiar with Scylla, a rack means a database, right? A cluster. That's good. It also has another log that can be well noted. This thing. This log entry indicates that the operator thinks it's time to scale up the rack, which is good because I told it actually to stack up 3 instances of Scylla. So at least a little bit scaling up should happen at some point. Where are we? Okay. Scylla, let's look at some Scylla pods. What do we get? We have them. And that's good. There are 3 of them. And they have 2 containers. I will explain this shortly why there are 2 containers. It's nothing nefarious, just we run some other things alongside in the same pod. What do we have from Scylla in the Scylla logs? Ooh, here, great. Let's first see if we can find at some point early in the lifetime of this container, we can actually see regular Scylla logs. For all of you who have ever run a Scylla, these log entries are very familiar. Compaction notifications. So here we have a running Scylla instance, and we have something else at the end. Also this word again, reconciliation, starting it. This is a good sign, which will soon be made clear if it's not already for you guys. But this is all well and good. We have a Scylla cluster up and running, but what about someone using it? It's not very nice, or it's not very useful anyway, to have a database and let alone a database cluster of a highly redundant and performant database that doesn't do anything. So let's simulate that we have launched our new game platform and the users are going crazy and they are using our services a lot and puts load on our database. Thousands of requests are coming in every second, and you are anxious to see if your database works. So we use a stress tool, Cassandra Stress for this. It's fairly easy to work with. And as you can see here, there are a number of jobs configured for this. 6 of them actually. Each of them runs a number of threads, just hammering away at the database. And let's have a look, actually, shall we? Oh, this is great. We have an open Scylla cluster, but we don't have any load yet. This is interesting. Let me try again. It takes some time actually for Cassandra Stress to launch its instances. In the meantime, we can have a look at the design of the operator, which is fairly simple actually in its conceptual idea. As you can see, here is this word again at the bottom left, reconcile. Take note of this again as we watch what is actually happening. We, the little person to the right, is sending YAML to the Kubernetes cluster. This YAML is handed off to the operator because the operator has taken over management of the cluster. So, and you can see it has some interesting things. For example, it has a cluster name, Scylla cluster. Simple enough. It can be any name. You just need to remember it when you when you apply changes. Don't change it. That's fairly immutable. Other more interesting things can be, for example, the version. You need a version of Scylla. You need the number of nodes that we have. Under the racks, in the racks properties, we have a members field. And in this case, it says 3. It means that we want Kubernetes to give us 3 instances. So what does the controller do? Or rather, what does the operator do? Its main job is simply to observe what the current state of the cluster is. Basically, this YAML that you see. And if we send something new to it with a different value somewhere, its job is then to notify, to pick this up, calculate the difference, and reconcile the differences by simply, in the case of scaling up or down, this will result in an increase or decrease of number of nodes. So let's have a look in our cluster again, see if it has awoken. Let's try another thing. I have some tricks up my sleeve. I really don't know actually why it's not running. Let me check again, one last time. Okay, good. Let's continue with the architecture go through while we try to make a change to our cluster. See if that bites. We can do that by scaling down the cluster. And you will see that this is simply an execution of the kubectl edit command, as you maybe briefly saw there. And this is a horrible chunk of YAML that Kubernetes is presenting to us in our default editor of the terminal. And we will simply find the members field here. Can you follow my cursor? And we will change it to 2. And save and exit the editor. This will drop the number of nodes to 2, presumably. It is still 3. That's not at all surprising, because this reconciliation loop you saw before, it's not instantaneous. It runs at regular intervals, and at regular intervals it will try to note the differences.
Yeah, Henrik, just one more comment that you are using relatively small instances, but on practice, if you have nodes of many terabytes of data, downscale or upscale include, or outscale, sorry, include a lot of streaming, because you need to change the topology in the cluster. So the actual adding a node or removing a node can take some time, even hours, if you need to stream.
Absolutely. And this is actually a reason why I'm using scale down here. The reason is that scaling up is always take some time, because Scylla is doing a lot of optimization and tuning on startup, which is, if you give it a significant amount of disk, this can take some time actually. At least, sorry, I make it sound like it takes a long time. It doesn't take a long time in the lifetime of a database. It takes a long time in the lifetime of a demo. So that's basically why I'm doing scale down here. It's a little bit faster. But you can see here that the monitoring platform has observed that there is one node who is leaving, that is leaving the cluster. And for some reason, it's not picking up the load test. That was a little bit disappointing. It would have been nice to see. Let's continue with the architectural overview. So what the operator actually does is, you see here, we are again up to the right. We are the operator of the operator, and we send in our YAML. The YAML is translated into those blue boxes at the bottom. Those are Scylla instances. They all have a sidecar that runs and manages its own Scylla. And this sidecar, alongside with the Scylla manager agent that we have deployed as the second container in the pod that you saw earlier, the second pod, it's responsible for actually starting Scylla. Not only does it talk to Scylla, but it also manages Scylla process itself. The Scylla process is a child process of this sidecar. And you can see here, we have racks and we have data centers. Those are the normal Scylla concepts that we're working with. Alongside that, the operator exposes a number of services, because we want the rest of our apps to be able to talk to our Scylla instances. So, and to make it a little bit clearer, the abstractions that we're talking about is fairly simple. We have a member. It's a Scylla instance. It translates loosely to a pod. It's actually a container, but everything are pods in the Kubernetes world. So we have a member Scylla instance. It's a Kubernetes pod, and you can see we have 3 of them in the example to the right. Then we have racks, and everybody familiar with Scylla knows that we have racks. Also, if you're old, like we are, you also know that at some point you had racks in the basement that were basically racks of servers. And this is the abstraction that we have for the next level. And it's modeled in Kubernetes as a stateful set. And the thing about stateful sets, I can quickly brief you if you're not fully in the Kubernetes world, is that they maintain state over time. Like, let's say you assign this stateful set, or the Scylla, you assign it volumes for storing the data. You don't want Kubernetes to discard this volume just because the node temporarily goes down. You want it to keep it. The same goes for IP numbers. They're supposed to be persistent over time. And that's a very useful property for a database, for example, because usually they don't like that their network identity changes. So next level, which we have, is the data center level. It's usually made for redundancy reasons or geolocation reasons, stuff like this. And it's simply a number of stateful sets. One stateful set representing several stateful sets representing a data center. So, and all this is baked together in the cluster custom resource definition, CRD. You probably hear about CRDs a lot if you read Kubernetes documentation, or maybe you use them as well. So this is these are the abstractions that can be good to know when you read the documentation on the operator or Scylla and Kubernetes standalone in itself. Okay, we have at least been able to see the scale down. It has taken place now, and everything is working well. The number of instances has shrunk to 2, and we can quickly have a little look at this from the kubectl perspective. The pods are down, or 1 pod is gone, and only 2 remains. So this sidecar controller, a small note about this. It does a lot of things. For example, it manages, aside from actually being the parent process of the Scylla instance, it also watches and sets up config files during startup, for example. You can change the config in Scylla, for example, the Scylla.yaml, by storing it in a config map. The this config map will be then exposed to Scylla through the help of this sidecar. In the future, it will also do things like backup and restore. It will help with these things. It will do whatever you might want it to do. So we want you to come with feedback, and this is usually a good place for addition. Aside from that, we have the Scylla Manager agent, and it is the one, you see these arrows in the right image, the HTTPS transport. This is what it exposes to the rest of the operator and Kubernetes. A REST API that the operator can do to check the status of the partaking members, for example. It can use it to decommission a node. It can do everything, more or less, that someone might ever want to do with Scylla. This is normally part of the manager, Scylla Manager, which we do not have at this point in time. I think I'm approaching the end of my demo. Zach, over to you.
Thanks, Henrik. So thanks for taking the risk and doing live demo. It's always a stress for the presenter and fun for the rest of us. So thank you. So I will quickly cover the status of the Kubernetes operator. So first of all, the operator is available. You can go to GitHub. You have the URL here. You can download it. You can try it. There is a Docker image for it on Docker Hub. And in the documentation, in the code tree itself, there is documentation that explain how to run on Google, on the Minikube, and soon we'll have an example of AWS. We have a few contributors already for this project, and shout out especially for Yanis, one of the external contributors that play a big role in this project at the start. So we did a lot of things, but we still have a few things we want to do. Let me first cover what we already did with Scylla Operator. So as Henrik demo, we already support topology changes, downscale, outscale. We support multiple racks, even multiple data center, but in the same Kubernetes cluster. We support cluster management like a configuration map, update the configuration, doing running upgrade, downgrade without downtime. And we already support integrating with monitoring stack, Scylla monitoring stack with Prometheus and Grafana as Henrik demonstrate. So everything that is written here is work well, but we still have a lot to do. And this part is actually, we were also looking for a feedback. So what are we working on now? And when I say we, it's mostly Henrik and the team. I try not to stand in their way. And so we invest a lot in testing. That's, I think, the major things here. Try to automate the testing and add more testing. So we can call it a production ready or GA. We are adding, as Henrik mentioned, support for Scylla Manager, that together with the Scylla Manager agent, which is already part of the pod, can run operation like recurrent repairs and backup right now to S3, but we are adding more destinations. We are doing extensive performance benchmarks on managed Kubernetes, AWS and Google mainly, but we are open for that to others. And we are doing all kinds of things. And we also get a lot of issue requests or feature requests and some pull requests from the community. So you are more than welcome to go to GitHub and start doing that as well. And with that, I think we can switch to the Q&A. Okay, so I will read out the question, try to answer them myself, and if I can't, I will refer it to Henrik, and you can still write down a question. Okay, so there is a, Henrik, maybe you can try it in the meantime. There is a comment here that your stress test didn't run because they were already defined and already run. So the command did not make them run again. Try deleting them and then recreate them.
Shall we try? We can try.
Yeah, go ahead and try, and I will, in the meantime, read out other questions. That's probably the case, yeah. Okay. I run in a question from Robert Gauguin. I hope I pronounced that name right. I run bare metal Kubernetes. Will you have a tutorial for that? So I know we have tutorial for Minikube, but Henrik, I think our explanation actually do cover bare metal Kubernetes. Is that correct?
We haven't done anything special, at least for non bare metal installs of Kubernetes. It's supposed to work everywhere you have a Kubernetes instance running.
Okay, thanks.
That said, they can differ, of course, if you install Kubernetes in your own flavor or everything. We know that there are some issues with what's it called, OpenShift, that we want to work out, but haven't gotten to yet. So.
Okay. Another question from Luis about the storage that we are using for the demo and for general for running Scylla on Kubernetes. So usually we strongly recommend to run with an SSD storage. And I believe this is what you did in this case as well, Henrik. Is that correct?
SSD storage.
Yes.
Yes. Yeah, we want to run on local SSDs simply for performance. And the example you see here today is running on some eight Google provided SSDs with that also are rated locally on the host. So or in the it's a daemon set. So. Yes, local SSDs and RAIDs, everything you need to get the maximum oomph. That's true of all databases, I assume. But yeah.
Okay.
But if you're not as concerned with performance, there's nothing stopping you from having slower disks.
True, but I guess most people looking for Scylla do concern, at least to some extent, about performance. Yeah. And another question very much related from Pablo. Could you comment about the performance of running Scylla on Kubernetes? So we can't really, because it's something that we are working on right now. In the past, we did extensive testing of Scylla on Docker. And with some tuning and right usage of Docker, we did manage to get to performance which are very similar to running Scylla directly on bare metal. There is some degradation of 5%, but not much more than that. We are hoping to get to the same range with Kubernetes, but we are not there yet. We are still learning how to tune all the right parameters in managed Kubernetes to get there. And hopefully we will share results soon. So we are doing, and Mikal in particular is a leading engineer here that spending a lot of time running Scylla on managed Kubernetes these days.
It seems like I owe someone a beer or some beverage of choice, at least.
Yeah. Okay.
Yeah,
the demo is running now. So yeah, Henrik, your problem that you to prepare, you run everything in advance and then it won't run again. So you should always leave something for chance.
I guess.
Yeah, I think it was Henry input here to save the demo. So thanks. And just to show you guys that your contribution is meaningful, even during the webinar. Question here, we'll take 2 or 3 more questions. What is a scaled Kubernetes cluster ready in production? Can you use it to scale to 14 terabytes per node and 50 nodes per cluster? So my answer is yes and no. So definitely you can run Scylla itself with a 14 terabytes per node and 50 nodes, and people are doing much more than that. We haven't done this in production with Kubernetes yet. As I mentioned, we're not considering Scylla Operator as production yet. We're still testing it. Of course, you can do it yourself, and people do run Scylla on production Kubernetes for quite some time, simply with either with our operator or with different tools. So it is possible with Scylla. I cannot in confidence tell you how to exactly do it in Kubernetes and what other issues we might find in the testing. Okay. What are the database backup options available when running on Kubernetes? So I will answer again, not specifically for Kubernetes. I will answer the backup option of Scylla itself. So Scylla have an element, or Scylla Enterprise in particular, have a product called Scylla Manager that, as I mentioned, can run recurrent repair and backup to S3 bucket. And we are planning to integrate Scylla Manager as part of our Kubernetes solution. And so the data will be back up to S3. There might be more Kubernetes backup solution out there, but to be honest, I suspect that our solution will be better because we heavily tested the Scylla Manager and the Scylla Manager agent. And the tricky part here is to control the bandwidth of the upload to S3 so it will not exhaust the disk, because if you do, it might hurt your online performance and actually slow down the database. So we invested a lot of work in controlling the bandwidth of the upload and deduplicate SS table when you upload. I'm not saying you cannot do it yourself, but it's not as easy as it may sound. So once we do have manager as part of the operator, it's really much easier for you. I know of at least one production user of Scylla that already used Scylla Manager in Kubernetes, but we haven't yet automated the manager installed as part of the operator. So this is something that Henrik is working on these days. Future roadmap with working with services like Mesh and Console and such. We are looking at all of them, and integrating of some of them is either orthogonal, so we don't have to do anything specific for Scylla, or easy. And once we have, we will of course share it, but I cannot say more than that. And of course, it's an open source project, so if you need something specific, please open issue for us or enhancement request, or even better, send a pull request. Okay, hope I captured most of the question, probably not all of them. Apologize for those that I missed. Thank you very much, everyone. Thank you, Henrik. It was a lot of fun, at least for me. I hope for you as well.
It was indeed.
And see you everyone on the next webinar. Thank you, guys.